Now, as part of the precipitation process, we'll be talking right now collision and coalescence process. So, in a cloud with the top warmer than like minus 15 degrees centigrade, the collision coalescence process can play a significant role in producing precipitation. To produce the many collisions necessary to form a raindrop, some cloud droplets must be larger than the others droplets. Larger drops can form on large condensation nuclei, such as salt particles, or they may form through random collision of different droplets. So in the research, studies suggest that turbulence mixing between the cloud and its dry environment can play a role in producing larger droplets. As cloud droplets fall, air slows them down. The amount of air resistance depends on the size of drops and on its rate of fall. The greater its speed, the more air molecule the drop encounters each second. The speed of the falling drop increases until the air resistance equal to the pull of the gravity. At this point, the drop continues to fall, but at a constant speed, which we will call is terminal velocity. Because larger drops have a smaller surface area to weight ratio, they must fall faster before reaching their terminal velocity. So we can say that larger drops falls faster than smaller drops. In a calm day, there is not much wind blowing happening. A typical raindrop falls over 600 times faster than a typical cloud tiny droplets. Eventually, droplets overtake and collide with smaller drops in their path. This merging of cloud droplets by collision is called coalescence. Within a cloud, there can be both updraft and downdraft situation. If an updraft situation is especially strong, then droplets of different size can all be pushed upward. Coalescence may now occur as many droplets, like collision may occur as smaller droplets are pushed upward more quickly, colliding with the larger droplets in their path, attaching each other. So in the contrast, in some research in the laboratory studies shows that the collision does not always guarantee coalescence. Sometimes the droplets actually bounce apart during the collision. For example, the force that hold the tiny droplets together, we call it surface tension. So see, this force, surface tension are so strong that if one tiny droplet were to collide with another, the chances are the two would not stick together. So coalescence appear to be enhanced if colliding droplets have opposite electrical charge. An important factor influencing cloud droplets growth by collision process is the amount of time the droplet spends in the cloud. So we have known that the way cloud droplets in the warm cloud, which those clouds with the temperature above the freezing point, grows large enough by coalescence process to fall as a raindrop. The rain that fall from warm cloud is sometimes called warm rain. The most important factor in the production of the raindrop is the cloud liquid water content. In a cloud with sufficient water, and other significant factor we can say range of droplet size, the cloud thicknesses, the updraft of the cloud, and also we can say the electrical charge of the droplets and electrical field in the cloud are significant factor for the droplets. So relatively thin stratus cloud with slow upward air current are at best only able to produce not droplets, it's drizzle, smaller droplets. Whereas towering cumulus cloud associated with rapidly rising air can cause heavy shower. So we know how collision and coalescence process actually works. So and the velocity also depends on the size of the condensation particles, size of the droplets. And also we know that collision not necessarily all the time make coalescence. Sometimes it's bounce back and split apart. And also the surface tension we call the force helps. Also we know that two tiny droplets, if those are opposite electrical charge, they can attract each other and create bigger droplets. So all of the process, collision and coalescence process here. So now we will be talking about seeing how cloud with temperature below freezing are either able to produce precipitation or ice crystal or not. That's process we'll be looking at.